Hi, welcome back to mcclatcheymaths. My name is Natalie McClatchey and today we are continuing our video series on algebra. We're going to talk about how to write an expression. In this particular video, you're going to learn some key terminology. We'll do a few worked examples and then talk about what's coming up next. Let's get right into it. First of all, I have a free resource for you today. You just need to contact me at mcclatcheymaths@yahoo.com and I'll shoot that over to you. So my resource today is some key terminology about operations. Now you'll know from maths that we use words that you would find in other parts of the world and they mean different things in maths. So for example, the word expression, which this whole video is about, if I said you have a lovely facial expression, that means something completely different in maths. Same with the word operations. It's not about going to hospital and getting your tonsils taken out. It's all about addition, subtraction, multiplication, and division. Now, in addition, we can ask in worded problems for you to do an addition, but we ask it in many different ways when we are speaking English. So we might say find the sum of, we might just use the word and, we might say combined, or together, more than, or plus. And there's others as well. This is not an exhaustive list. Subtraction, we might say less than, take away, minus, fewer, difference, or decrease. So we're going to use some of these keywords in our problems today. For multiplication, we might say double or triple, per, at, or give a rate. We might say product, times, power, square, or cube. These are all giveaways that we are wanting you to do some multiplication. And for division, we might talk about sharing equally, distribution, halves, thirds, quarters, fractions, equal groups, and splitting. So this is the resource. Please contact me if you would like a copy of it. All right, let's get straight into some worked example where we're going to use these operations in some worded problems. First of all, we're being asked to write an algebra expression. Now what this means is we are not going to work out a total that's going to be a number that we can use in a real life situation. An expression is not a formula. It is not an equation. There's no equal sign in it. So that's important to remember. It's going to be some sort of an algebra statement that we're coming up with, but we will be able to use it to work things out if we needed to. So in this case, we're wanting to work out the number of tickets to be bought for Y girls and 13 boys. So because we've got that variable of Y in there, we're never going to know how many tickets we need to buy because Y is in there. However, we could use Y to substitute different variables in. Now, what I usually say to my students is firstly, look for the key words. The key word in this is and it tells us we are going to be doing some addition. We could simply jump straight to the answer. And once you get better at these, you'll be able to jump straight to the answer, which is Y plus 13. Notice it's not 13Y because we can't combine Y and 13 together. They're not like terms. However, a lot of students, once they see worded problems, immediately start to panic a little bit in their brain. So what I say is pick an easy number. An easy number is 10. An easy number is also 1. They're easy numbers to work with. So I say, well, what if there was 10 girls? Do you know how many tickets you would need to buy for 10 girls and 13 boys? And they say, well, of course, I need to buy 23. And I say, well, what did you do? How did you work out it was 23? The answer they say is, well, I added them in my head. And I said, well, that's exactly what you're going to do, except this time you don't know that there's 10 girls. There could be 1 girl, 10 girls, 1,000,000 girls. Doesn't matter how many girls, there are Y girls. So for the number 10, we're going to replace that with the letter Y. And because you did addition, we're going to pop the plus in between the Y and the 13. Now, once again, because they're not like terms, I can't simplify that any further and work out the total number of tickets. And I'm not even asked to work out the total number of tickets really, because I haven't been given the request to write an equation. Let's look at worked example 2. The cost of seed cakes at $8 each. Now, once again, I say to students, okay, ask yourself, what would you do if you knew there were 10 cakes? And they say, well, that's easy. The answer will be $80. And I say to them, well, what did you do in your head? And they say, well, I did 10 cakes times $8 each. So the key word here is at. At is like a rate. It's telling you to multiply. So they know that they needed to multiply, so they could simply do C times 8. Now, in algebra, and we're going to talk a lot more in our next video about multiplying and dividing, but in algebra, when we have this multiply symbol between a letter and a number, we're a little bit lazy, and we just simply write it as 8C. We take the times away because it can be confused with an X. We typically put the number before the letter, so it's 8C. Okay, worked example 3. The quantity of mince for one recipe of 1,000 grams of mince is shared equally across are recipes. Our keywords there are shared equally. That tells us to divide. So now that we know that we're dividing, it becomes 1,000 divided by are recipes. And that's all we need to write for an expression. Now, in algebra as well, particularly as we move into more complex algebraic techniques, we typically write it as a fraction. This symbol here between the 1,000 and the R is a divided by symbol. It's called a vinculum. We see it in fractions all the time. It means the numerator is divided by the denominator. So this makes it very easy later on when we're building more and more complex algebra relationships to work. Whereas when we have this divided by symbol, it can become a little bit more simplistic because you can really only do that dividing unless you're using loads of brackets. So that's why we usually present that as a fraction. All right, this time we're going to look at some combinations of operations now. So we've got 8 less than m. And in this case, less than tells us we're going to be doing a subtraction. Now, this can be a little bit tricky. It's very tempting to simply write 8 take away m. And most students will jump straight into doing that. However, you need to think about this. If I said that m was 50, 8 less than 50, you would know that the 8 is less than the 50 and that you would need to do 50 take away 8 to get 42. So in that case, and in this particular situation, m is actually bigger than 8. It's 8 and it's less than m. So we actually need to write that as m take away 8. Let's do some combinations now. We've got 6 more than, so that's implying an addition, and double j, so that's implying multiplication. Now, a lot of people think double means you are multiplying j by itself. You're not. If I said double 6, you wouldn't be doing 6 times 6, you'd be doing 6 plus 6 or 6 times 2, because that's what double means, to multiply by 2. So in this case, it's 6 more than, 6 plus 2 lots of j, not j squared. Okay, so think about that one through again. You may need to just rewind and re-listen to that, but double means multiply by 2. It does not mean to multiply it by itself. Writing an algebra expression for the sum of x and y, which is divided by 8. So once again, we've got sum, which means addition, and divided by, which is pretty clear. That means divided by. So the order of operations here is important. It's not x divided by 8 or y divided by 8. It's x plus y, the sum of those two together, and the answer incomplete is divided by 8. And our last example today, the square of the difference between m and n. So once again, we've got square, which is our keyword for multiplication, and difference meaning subtraction. The difference is between m and m. M and n are taken away from one another, and we are squaring the result of that. So that means we're going to need to put the m, take away the n in brackets, and we're going to raise that to the power of 2, which is the square. Now, if I just did the square of m squared, take away n, that would not be giving me what I'm asked for in this question. So it's really important to read the question carefully and to make sure that when you've got your answer that it actually reads exactly the way that the question's written. Well, I hope you found this helpful today. If you did, why not tell someone? Tell us in the comments, or like and subscribe to the channel. Don't forget, you can contact me at mcclatcheymaths@yahoo.com to get a copy of our key vocabulary resource. You can also follow us on Facebook and Instagram for more tips, tricks, puzzles, and competitions. Thank you so much for watching today. You've been watching McClatchey Maths. I'm Natalie McClatchey, and have a wonderful day.